Hey there. Hopefully you can hear me okay.
Yep. Thank
All
you
right.
very much.
Thanks, Hugh. So shall we go ahead and get started? I have a couple of folks with me today, and we'll talk, as Hugh mentioned, we'll talk about Popper and thinking in terms of the cloud native, container native world. Certainly, containers have really caught the industry's attention. Take it one step further and take container orchestration and Kubernetes, really a huge project across the industry. In my mind, really taking some of that focal point that we saw around Linux as a low-level operating system and expanding that to be clustered data center type infrastructure for applications. So here we get to learn about Popper. I'm actually interested in this one for a number of reasons, but I'll wait till after we hear a little bit more of the details to dig into some questions. I thought it might be useful first. Let's just a quick intros of Ivo and Carlos, and then Carlos will start off by giving us some background more broadly beyond Popper to actually introduce the cross program. So Ivo, Carlos, can each of you introduce yourselves and just give us a brief bit of your background?
Sure. Thank you, Chris. I'm an adjunct faculty at UC Santa Cruz for computer science and engineering, and I'm the director and founder of the Center for Research in Open Source Software.
And my name is Ivo Jimenez. I'm a research scientist. I work at Cruz. I'm a fellow there, and I am also a graduate from the PhD program there.
Fantastic. Maybe little known fact, I'm a banana slug, so go banana slugs. Oh. And we have some other folks at Red Hat, not the least of which would be Sage, who's worked a lot with UCSC and created ultimately what we would call Ceph today as part of his work at UCSC. So a lot of history together. Looking forward to learning maybe a little bit more. We can start with a little bit more about Cross, and then we can jump into the Popper project.
And I also want to thank the organizers of the Red Hat Research Days to include not one, but two cross projects into the program. So last week, you heard about the cross-funded live hardware development research project. And today you're going to hear about Popper, which is a cross incubator project. But let me briefly introduce Cross and also say that, when I joined UC Santa Cruz in 2005 as a research scientist, I just spent 5 years at NetApp as a performance engineer. And then in 2008, I actually joined the faculty and graduated 9 PhD students and 10 master students since then. Let's see whether my cursor, okay. So one of my first tasks when I joined UC Santa Cruz in 2005 was to lead a summer project to write a journal paper summarizing all the object-based storage research that was taking place at UC Santa Cruz. And participating in that project was a second-year PhD student called Sage Weil, who quickly created a running prototype that we ended up calling Ceph. That's actually short for cephalopod, which is related to the banana slug, which is, as Chris already mentioned, as UCSC's mascot. So this turned to his PhD project that was funded by 3 DOE national labs, Los Alamos National Labs, Sandia National Labs, and Lawrence Livermore National Labs. And then a year later, we decided to open source Ceph. And then after he graduated in 2007, he did something revolutionary. He actually continued to work on his research prototype. Not many people do that. And the combination of him having the means to do that and having it open sourced basically was the requirement for the history that followed. In 2014, 10 years later, after he wrote the first line of code that ended up in Ceph, his work really paid off. Hearing about the InkTag acquisition, Sage's advisor, Scott Brandt, and I approached Sage to talk about a monetary gift to Santa Cruz. I really learned how important that is to ask, because Sage agreed to give me $2 million to create a structure within the university that would enable other students to have a similar career as he did. And this career enabled open source and the means to spend time to growing development communities around a research infrastructure and prototypes. A year later, I kicked off Cruz, that from the beginning was also sustained by corporate memberships and very much operating like an industry university research center. So what is Cruz? So the Center of Research in Open Source Software functions as a bridge for students at UC Santa Cruz to learn how to productively engage in open source communities, to become high impact researchers, leveraging open source strategies and techniques, and to continue working on their research prototype after graduation and build a community of developers. So Ivo is actually, who's going to speak next, is a great example of what I was hoping to achieve with Cruz. He was a research fellow and is now an incubator fellow. And that allows him to continue to work on his research prototype Popper that he built for his PhD project, which was on agile research delivery. So I want to close out to just mention our fantastic advisory committee that we have at Cruz. Doc Cutting, Karen Sandler, Nisa Strottman, Sage Weil, and James Davis, who's a UC Santa Cruz professor who's interested in entrepreneurship within the university. Without them, Cruz wouldn't be where it is today. So if you want to know more, don't hesitate to contact me.
Awesome. Thank you, Carlos. And I really appreciate the work. It's one of the areas that our much smaller research organization at Red Hat focuses on is that same space of connecting interesting ideas and research to open source communities. And certainly from a Red Hat point of view, we look at how that turns into creating impact within our products. So, commercial outlet, really important to, in my opinion, to draw that connection from research to the industry, to commercial world. So it's part of how we can make change. So I really appreciate that work. Ivo, can we jump to you and learn more about Popper, just getting into the container native workflow, and learn what you've been up to.
Sure. You see my slides, right?
Yes, thank you.
So this is a brief introduction to the Popper project. Popper is a container native workflow engine. And as Carlos mentioned, this is an incubator project at Cruz. And I'm going to describe how we use Popper in general. And then I'm briefly going to discuss how we use Popper in our lab. And maybe we can discuss more in the discussion session about what people are doing with Popper. But the idea behind Popper is to take the container native approach and apply it for the research process. I guess I don't have to introduce containers to the audience, but just for the sake of completeness, containers are this great new technology that allow us to package all the dependencies of an application and share them easily. And it has revolutionized the way people are working through all the great projects we see today, Kubernetes and such. And one of the main benefits that we see from the point of view of research is that you basically bring your own environment to share infrastructure, as Jason from Community nicely explained in the previous talk. So we can, things that we would take like days to do, like setting up a LAMP stack, or even like compiling, like, I don't know, TensorFlow with GPU capabilities, it's now just a single command. So the idea behind Popper is to take this approach, push it to all the different phases of a project. And in the case of research, when we work with things like Ceph, or in general, like low-level libraries where you have to do a lot of work in setting up a development environment, building software, testing that software, deploying that software, testing it, benchmarking it, and then summarizing results, generate graphs, all the things that we do as part of the research process, and communicating research, which is the most important part when we're done and we want to publish papers and share our results. The container native approach is apply containers to all these stages. And basically what that means is we don't install software directly anymore. Instead, we package containers, and everything we do is in containers. So if we do this, if we embrace the container native paradigm, what happens is we start finding some things like having to deal with multiple container images, a workflow that it's not only dealing with one image, but a set of images. And what we find is that there are usually, if you install like Docker or Podman, there is this need of being able to connect and create workflows that are using multiple images. There's also these a lot of container engines out there, and it can become very overwhelming if you're starting with containers, and because each of these serve different purposes. So, and then lastly, there's this lack of common orchestration platform. We have Kubernetes, which is great, but not everybody is running Kubernetes. So we want to address these in a more systematic way. So what we're doing is with Popper is trying to address these three things. On the first in the first side of expressing the workflows, what we have is a very simple YAML syntax that allows you to just connect task. It's a task, automating a task of invoking an image, passing some arguments, and running it. If you've worked with Google Cloud Build, it's a similar syntax, and it's also similar to the earlier version of GitHub Actions, the alpha version of GitHub Actions, but they moved away from the syntax. It's just a simple YAML file that allows you to express and codify what you're doing with containers. And the CLI tool allows you to quickly git clone and do Popper run on a repo that has these YAML files. And if an author or someone that is sharing this worked on making it self-contained, then everything you need is there. You just do git clone, Popper run, and then you're reproducing what someone else has done. That addresses the how do we express multi-container workflows. Now, what about like different engines? So when we work with containers, or what we commonly do is just use Docker or Podman and then run a single container. But then, depending on when you run, you might need to use other container engines. And then each of them have their own particular ways of dealing with those and creating images and whatnot. So, as I mentioned, for someone that wants to basically just run a workflow, run a series of tasks, these might not be too welcoming. So what Popper does is basically abstracting between all these different engines and doing the work for example, exchanging between image formats or pulling from different registries and all the different things that each of these engines have in particular. So if you do, for example, Popper run, by default it runs in Docker, but you can say, okay, I want to use Podman now. And it's exactly the same workflow, same YAML file, same sources. It's underneath is going to be using Podman. So it's an abstraction layer over multiple container engines, Popper. The other one is orchestration platforms, and when you're running on shared infrastructure, we have a similar scenario where we have a workflow and then a list of different resource managers or schedulers. And then for each of them, I would need to, if I want to work with containers, I would need to specifically do things for each of these. And with Popper, we're abstracting this. We can say, okay, Popper run runs on your host, and it's going to use the engine of your host. If you say, okay, but I'm running a Slurm, and then it's going to actually do things that might leverage the underlying Slurm and thus the resource manager, which in practice means that if you have one of these steps, it's an MPI task. It's actually going to launch MPI task, same step that you would locally in your machine you do in multiple CPUs. It's now going to launch it and scale it up transparently. Same for CI services. We have a lot of CI services, and those are really nice, help us a lot. But then if I want to have a workflow, each of them have their own syntax, their own particular way of running things. And with Popper, we abstract this and say, okay, this workflow, I want to run it on Travis. Now, can you generate the config files for Travis? And then Popper will generate those files for SQL CI, for Jenkins, and others that we support. That's pretty much Popper in a nutshell. Our motto is one workflow to rule them all. Same workflow from the point of view of researchers is I want to work on my logic, workflow logic, and I don't really want to waste time or invest time in how to run this. I would rather spend it in generating new research results, and new findings. Examples of things that we currently do, for example, we work a lot with Ceph, as Carlos was mentioning. So we create workflows, for example, for deploying Kubernetes on a bare metal system. Cloud Lab and Chameleon, for example, are NSF-sponsored clouds that we use to deploy Kubernetes, then deploying Ceph via Rook, running benchmarks, plotting results on Jupyter notebooks, and having all that automated in the form of workflows, of Popper workflows. Another example is a C++ project where you have the more complex the project becomes, the harder it is with dealing with development environments. And when we're in teaching this, students don't have that much time to catch up in terms of setting up the environment. So we package the environments in containers, and we have all they need to git clone a fairly complex C++ project and be able to build and run tests like pretty quickly. And also the follow-up steps, which is running unit tests, running on-function tests, and deploying infrastructure and whatnot. Machine learning, we're doing same. If we have machine learning libraries that are not just, for example, pure Python libraries that are using C++ libraries underneath, we go and build all those libraries, install the Python packages, download datasets, train, evaluate models, and show results again. And many other examples that we have that people are using Popper for in different domains. That's in a nutshell what Popper is and what we're doing with Popper. You can find more on the GitHub repo. You have an organization, and you can find ways to contact me in this URL. Thank you very much.
Awesome. Thank you, Ivo. I'll go ahead and just jump into some questions. Now, I'm compelled to ask the naming. I'm picturing yes. Popper as like push-D, pop-D, kind of like there's a stack and you're trying to pop the stack. But how did you come up with the name Popper?
So it is based on a German philosopher of science, Karl Popper. And he is the one that coined the term falsifiability or falsifiability, which is one of the criteria for determining whether something's scientific or not. But I heard later that it's also like in Korea there was like poppers that would be like breakdancers, a variant of breakdancing.
Okay. Means different things to different people.
Yes.
Why don't you give us a little bit of compare and contrast? So there's some other ways to do things like this, and maybe one reasonably well-known example would be the Docker Compose tool, which uses a YAML file to sort of instantiate multiple container images. How do you see Popper different? What did you bring that's new and unique to the world here with Popper compared to Docker Compose?
Yeah. So the idea behind Popper is the same. So you use a YAML file. The main difference is Docker Compose is used to spin up services that are always running. Whereas the goal of Popper is to have like a finite set of tasks that have a determined like horizon. You start something, you finish end to end, and it's a job rather than a service that it's always running. But a lot of the syntax we borrow from it, and also from Google Cloud Build.
Got it. Thank you. And when we talk about that syntax, Cloud Build, sometimes there's just a canonical way to do something. Other times there's somebody who's done a great job and just follow their path forward. What's the relationship here between the Popper YAML and Google Cloud Build YAML, and how did you come up with the syntax?
Actually, we found later Google Cloud Build syntax, and that's why it's actually different in some keywords. But we actually started supporting first the earlier version of GitHub Actions, which was a more Terraform based kind of syntax, but they moved away for the GA of GitHub Actions, and we kind of like really like that approach because it's very lightweight, low overhead, and our goal is to keep the syntax it's just a thin layer between running bash scripts and running a workflow, and that's kind of like the principle behind it. Makes
sense. I think in the description around Popper and you go to the GitHub page or getpopper.io, and you'll see some key language like container native workflow. How are you kind of contrasting container native versus cloud native? And then there are other open source projects very broadly in this space of workflow management and CD, and there's many ways to slice and dice problems in this domain.
Yes.
Argo, Pachyderm, running more directly on Kubernetes. So what are you think? Help us understand that kind of distinction, container native versus cloud native, and then what are some of these other tools that exist and where Popper fits into that broader ecosystem.
Yeah, the difference or the way we define container native is basically doing everything on containers, right? The main difference is that we don't need Kubernetes. We can run on Kubernetes, and we actually support running. We have this abstraction of runners, as I showed in my slides, so we can actually run on Slurm, run on Kubernetes, or other batch schedulers and resource managers. But it's not exclusive, and I think that's the main difference. In the cloud native world, you assume you have a Kubernetes instance available to you, and we find in practice that some people find Kubernetes quite complex to deal with if you're more on the science side of things. And so their goal is to only need a container engine locally, and that's it.
So we work in the Kubernetes space, and even if you're not on the research science side of things, Kubernetes can feel complicated. So there's challenges all around. A lot of ways to slice and dice. How do you make it easier? I guess in that context, domains that you're focused on, we've got container native as a technology domain. There's that sort of services versus finite tasks. There's clearly the orchestration piece of bringing multiple containers together to achieve a task. Is there a domain that you're really targeting? Data science, life sciences, other areas that you're really focused on?
Yeah, the goal is to be domain agnostic, but to capture domain specific knowledge in the form of containers and the workflows themselves that get expressed. But from our point of view of the engine and in running workflows, we want to stay agnostic, and have people build catalogs of images, catalogs of workflows where you're capturing all the domain knowledge, because there are things that you for which you will need to deal with, like maybe like in the examples, you need to build C++ code or deploy a cluster of machines, and sometimes that's not easily done unless you're dealing with very low level stuff.
Right. I really like that language you used around the domain expertise that sort of gets encapsulated in a container image and even more broadly in the workflow description.
Yes.
I think a huge part of the value of containers and containerized workflows is offloading that domain expertise to somebody with the domain expertise, but still being able to leverage it in a consistent, repeatable manner. So really, certainly important in experimentation, and really just generally useful for making people efficient and effective. But thanks again, Carlos and Ivo, for the description. This is really meant to be more freeform and just have a dialogue with the folks that are really interested in learning more about Popper, and certainly Cross as well. It's a much broader topic, but I'm sure Carlos would be happy to talk about that. So feel free to just jump in and ask questions. You just need to click on the Ask to Share.
And when you ask to share, know that you're going to share immediately. I made that mistake in the last one where my face just showed up in the middle of the conversation. I thought I was going to get approved or, something. No, you're going to be in right away. I have a question about, can you just go over a little bit more on the abstraction layer and what's happening underneath to talk to the different APIs or
yeah. So we have a workflow representation that all Popper it's implemented is in Python. So it's a Python. So we have Python abstractions for representing a workflow, and then we have runners, and we have a pluggable architecture. Maybe I can share that. Let me.
Yeah, I can.
So we have a pluggable architecture that allows you to implement different plugins for different engines. And in the case of so we have a parser that creates the workflow objects, and then we have these larger abstraction of the workflow runner. And then for each resource manager or batch, we have different. We have another one, which is the host one, which is when you run. We don't use Kubernetes and Slurm. And then for each of these, we would interact with, like in the case of the host one, which is when you run on your machine, we're just using DockerPy, which is the Python binding for Docker. In the case of Podman, since the transition to 2.0, it's undergoing, and the Python APIs are also in flight. So we are basically just chilling out and running on using the Python subprocess.
So
the Python subprocess module.
So this research project is across a lot of different environments. So for Red Hat customers, is there part of this then that will be focused towards OpenShift or OKD or whatever, and then finally get pulled down into something that somebody has an operator for to deploy within OpenShift? I'm trying to understand that part of it too. What sort of efforts have Red Hat been doing to take this into our open OKD and OpenShift environments? Or do we know?
I'm not aware of anything. What we are planning to do is, or it's to have so right now we support Kubernetes, and that runs fine. So the only thing you need is a kubectl config file, and the workflow runs as if you were running it locally. And then how to use that as a building block for other things, that's what we're currently exploring. One option that we're considering is to have some sort of SaaS type of framework where you have multi-tenancy and where you have researchers that can create like logins, and you would quickly log in, and then underneath you would create a namespace in Kubernetes, and then have, for example, if a researcher is working on, I don't know, a laptop or a tablet, which is not equipped to running, for example, machine learning tasks, you would test the workflows locally, and then you would say, okay, I want to run actually this workflow, I want to run it on Kubernetes, and this particular machine that has GPUs and whatnot, and then you just run it, and the idea is to have that experience be seamless, right? But it's a seamless integration. It's the same goal. And then moving forward, we would then look at maybe creating dashboards, maybe being able to schedule the workflows, maybe like things that would allow you to schedule something and forget rather than being interactive.
I'm wondering too, could a Popper workflow be put inside a operator, a Kubernetes operator? Or would that be overkill? Or could a Popper workflow orchestrate a bunch of operators or something? Do you know what I mean? I'm trying to understand the relationship between those.
Yes. No, I think, that's a good question. I would say the latter. So for example, the other thing we're working right now is, I don't know if you're familiar with Airflow. Airflow is a workflow execution engine that it's very popular. Like Google has a service for running Airflow, and being able to run there and schedule workflows there and have that integration with Airflow, so that you don't have to write, because Airflow, if you write a workflow in Airflow, it means that you have to write basically Python code that expresses the workflow. And we want to do that transparently. Perfect. So you just specify your YAML file and say, okay, I want this workflow to like an upgrade. So Airflow is used for a lot of automation all over. It's a domain agnostic, so people are using it for many things. It's kind of like a cron.
Got it.
A cron plus. So something like that, where you say, I want this workflow to run every week, and it's gonna maybe just run like functional tests or enduring tests for a project, or upgrading machines, upgrading software, things like that.
Perfect. Thanks.
Yeah, thank you.
Amit, did you have a question or a comment?
Yeah, hi.
Thoughts or
talk, by the way, and I have a question. Can we? Does Popper allow GPU support, and can we do replication of the model like while training?
So you can. Popper is domain agnostic. So anything that you can run on containers, you can express it in a workflow. So if you have already a container image that it's properly packaged for leveraging a GPU, Popper allows that. It's not it's not jumping into the domain, rather just orchestrating the set of steps and the containers associated to those steps.
Yeah. Is there any tutorial like POP are used for computer vision tasks like segmentation or object detection kind of stuff? Like
we have so we had a summer student this summer, and she worked on comparing machine learning performance, machine learning libraries, like two libraries that are doing the same thing. This was a classification task, but we have other examples. And in particular, we have a workflow that has a benchmark from MLPerf. MLPerf is an organization that is working on defining benchmarks for machine learning. Yeah. So there's an object detection benchmark that we have quote unquote popperized, and that's also available. I don't know, can I share things here?
Yeah, that'd be great if you could share the link of, could be tutorial or the project.
So this is the first one that I mentioned. Okay. And then you can see that link, right, on the chat box?
Yeah.
Okay. And then the other one is here. Yeah, and we'll be happy to help. Let me know if you have any question.
Yeah,
we also have a Slack channel, a Gitter channel, and
I didn't know this by the way framework before, because I was using OpenShift for the deployment, basically machine learning and model deployment. So I wasn't aware of this.
Totally.
Thank you.
Yeah, no worries. Thank you.
So I had a question. One of the things that struck me in workflow description, the serverless space creates, jobs that run to completion, and often there's connectivity between those jobs so that you're potentially needing to define some sort of workflow. Have you looked at where Popper intersects that serverless world? Certainly, in the...
Yeah, I haven't looked yet. There is, I don't know. That's a good question. You mean like communicating, like if you have a task running here, and how could you communicate between, for example, two workflows, or one workflow triggering another and things like that?
I think the communication piece might get handled in the serverless framework, which would be, yes, a REST call API to some a REST interface that is used to call into a function that's not there until you make a call into that REST interface. But there's potentially some workflow logic, just like you were describing that cron plus. One of the things that you could do in cron is, write a bash script, and that bash script would be executed at a time event, and it may have a whole set of activities that it's orchestrating that bash script. The serverless function of function as a service type environment, an individual function is going to respond to an individual event. You may be defining a workflow that's responding to an event, which is something like the relationship between cloud build to cloud run. Cloud run just doing a single container launch, really simplistic container launch, giving you that orchestration. If you think of cloud run as a serverless function, it's a little different, but it's in the same general space. Is there a connection here where there's workflow orchestration for that sort of event-driven workflows? So a series of steps you want to take in response to an event, as an example, which are each discrete functions.
Yeah. Yes. Yeah, I think there's room for that, and then the fact that you only need the container engine, it would definitely be possible. But then, yeah, I don't know. It's something to explore.
Can I?
detail.
Yeah, can I jump in here? So I think that
you're
maybe
muted, Carlos. Oh no, sorry.
So is the thought that you might see the serverless function framework as an alternative to the Docker framework or the container framework? So that you could, instead of using, so I think Popper is assuming Docker. Well, actually, it's not true. It's assuming multiple kinds of container frameworks, but you could also have a serverless function framework instead of the container framework. That would be very interesting, I think.
Yeah, that's how I was thinking of it. More. So if you think of under the hood, what might happen in a serverless environment is you have code, application code, your function, your response to an event. That application code has a runtime, and that runtime has dependencies, and that code, runtime, and dependencies are in a container. And when you get an event trigger, you launch a container. The serverless function author may not be aware that that's what's happening under the hood, but that's certainly how it works in Kubernetes. And when you start to connect multiple functions into a workflow, kind of like a Unix pipeline, there's something, your command line that tied together that said, here's my workflow. It's ls pipe, grep pipe, awk, whatever. I suspect there's similar challenges in the serverless space, and I suspect a workflow orchestration will be useful there.
I see. Yeah, I get it now. Yeah, totally. Like having like a runner that instead of assuming Kubernetes or trying to run on the container engine, it's actually running on the frame. So distributed, it's effectively a distributed workflow that it's expressed in that YAML file. Yeah, that's interesting. Yeah, and what use cases do you see for these, or do you have something in mind?
I'll start with the kind of classic reference use case for a serverless function. Upload an image to an S3 bucket that generates an event. That event triggers, say, image review and a label applied to the image, and maybe a thumbnail created. You could certainly imagine that function itself creating an event and some subsequent logic that needs to stitch together a workflow of events, that a workflow of functions that might need to happen on an event. Some of those would naturally trigger an event for the next function, so that the serverless platform can take care of that. That's sort of what it would do. Some of that needs to be externally described, and that would be the workflow. So that's how I was picturing it. So now you upload your image, but you do a series of events well beyond the compressed thumbnail label, and it just a little overly simplified, but that's kind of the picture I was coming up.
Yeah, totally. Yeah, in general, anything that you would do currently, but expressed as a workflow, as a popular.
you answered my other question, which is what languages are written in, and then the Python implementation of workflow YAML. If you just said those words to me, I would say, "Oh, you're talking about Ansible." So, where's Ansible in your thinking?
We actually use Ansible for example, Kubernetes deployment. We're actually using Spray, the project that it's Ansible based.
Yep.
So we have Ansible Docker images, and then it's got. So the way we look, or the way I like to think of Popper, is a meta workflow. It's like the workflow that runs the workflows.
Right. Yeah.
And or the things that you would otherwise be doing manually, like logging into a machine and then invoking Ansible playbook. And then if you for example deploy Kubernetes and then you write instructions in a README, this is how you deploy Kubernetes. You go to the kubespray GitHub page and they have that README. You can Popperize the README and say, hey, this is a Popper workflow that does what we just described in the README.
We do some work. William would probably be familiar with this. We create these things we call reference architectures. So here's how you want to do high throughput transaction processing, especially if you're trying to do some benchmarking. And the reference architecture historically would be a 100-page document of every detail of how you set up your system. In there's English language and then command lines.
Yes.
And a much more modern approach is turn that into some descriptor that you could execute. So that's makes a lot of sense to our sort of reference architecture world.
Yeah, that would be, I mean, when we talk about this with regards to portfolio of products, Ivo, did I pronounce your name correctly, by the way? Yep. So Ivo, okay, sorry. When we do this, trying to automate different parts of it would be really powerful. From, we can use things like Ansible at a lower level to do some infrastructure parts, but then trying to put these workflows in terms of containers and also in terms of the CI/CD thing. So, for example, one of the ones we're working on right now is an edge artificial intelligence, machine learning use case for manufacturing. And there's a lot of different pieces we need to do if we're setting this up, not just with customers, but also within our quality engineering group. And there's lots of different pieces. So something like Popper to help us automate after we've gotten the infrastructure in place would become very, very useful and help us to repeatably and consistently deploy things in the right way, especially when it comes to quality engineering.
Yes. Yes, that's kind of like what we started with, because that's kind of like what we do when you're doing systems research. You're kind of like a performance engineer, and you're that's what you do, like effectively. Yeah. And you deal with a lot of infrastructure stuff, and then if what you're dealing with has a CLI interface, then that's it, right? Then you start automating things, start writing scripts, automating everything. And then if everybody starts from scratch, it's a lot of waste. And I'm kind of like, I hate waste. That's where we found containers in our lab, we found Ansible, and then we kept escalating the reducing waste ladder.
Right.
And then we get to something like Popper.
Right, and when you're not productizing something big like that, because it can't be, right, in many ways. What you do want to do, though, is make it very easy and consistent for the customer experience, and also for your engineers in quality engineering to set things up in the right order to make sure that your messaging systems are set up, you know, your Kafka streaming pieces are set up, your CI/CD containers, all that stuff is set up for your Open Data Hub in our example that we're talking about for the AI/ML components. Everything needs to get set up in a certain order, and you don't want to waste time with figuring out, well, what happened? I did this last time. Well, you did something out of order. Well, with something like Popper, you can consistently set things up in the right order and make sure that that it's very repeatable. Yeah, this is definitely a space to watch.
The students in my lab actually adopted it without me telling them to, which is I never experienced something like that to be becoming popular, right? Even though it looked like a burden.
Can you explain? Can you explain that a little bit more, Carlos?
Solved the problem they had. That's the waste
thing.
Yeah,
so basically when we write papers, right, that's our main product, right? Students and papers. We always have experiments, we have to generate graphs, we have to, you know, do all these things. And students really found that their work is much more cumulative instead of this one shot to solve a problem right now because it's urgent, there's a deadline, and then you have to redo everything again, you know. So they found that their productivity incredibly increased, and you created sort of this library of how to get things done, automation. And it's incredibly useful in the classroom because now you can actually get people much more up to speed more quickly when you know we have a quarter system. So in order to do class projects, they have only 10 weeks, and they can do a much more complex things because there's all this automation in place to do that, right? And so it just elevates teaching on a completely different level. So it's useful in many ways.
So one of the other areas I'm thinking this, just from an example of where I was working in the past, is there's not an awful lot of workflow work for containers and things like the animation industry and stuff like that. Because in the past they would set up a lot of machines and start jobs and do all that sort of stuff, and it was very almost like HPC sort of driven type problems. Whereas this can adopt to that very well in the container world to provide animators with this ability to, I need to do all my mathematical calculations. Now I need to draw my images. Now I need to add in shading and coloring and reflective surfaces because I have all these super duper programs set up, but I need to put them in the right workflow to generate this wonderful image for the animation pieces and all these post-production. So this would be another area that could really benefit from this. Should talk to all the animation studios about it.
I had a friend. He used to work on the industry. And he would describe all the ad hoc stuff that people do for the rendering farms.
That's right. This would be perfect for doing render work in the animation industry to provide that workflow for them. They have a lot of the frameworks, but they don't have these frameworks to hook into something like your workflow tool to work with containers in the Kubernetes world.
Great pointer. Thank you.
Any other questions, comments, thoughts for Carlos or Ivo?
I just want to thank you thank you very much for having us and for making time for us and for those great questions and pointers and inspirations. So highly appreciate that.
Yeah,
Yes,
thank you.
Thank you very much.
Yeah, I really enjoyed this, so thank you. Cool.
Thank you.
Well, have a great day, everybody, and thanks for joining our first virtual research day. Hopefully the next one will be in person and we'll mix it up back and forth, but really enjoyed this. Thank you.
Thank you.